All right, here we're in chapter 2 on linear equations and one variable. This is section 2.3 on literal equations. Now, what is a literal equation? Well, it's synonymous with a formula, something we use in science or something like that. It's similar to solving general linear equations because we apply the same method. We're going to use a two-step method used previously, and so we'll be given some literal equation, and we'll be told to solve for one of the variables in the equation, and then we just work our way backwards until we get to that variable that we need. So if we look at these examples here, let's start with number one. It says we have a times b equals c. So this really isn't a literal equation in a sense science uses it per se, but we're going to solve this equation for b. Well, how do we solve for b? Well, we have to get rid of the a. So that means we have to divide by a. And so if we do that, we get b equals c over a. Now here, there's no numbers, but we were still able to do our usual method of solving these equations for a specific variable, and that's what we did here. Now the next one here, we have a volume equation, and it asks us to solve for pi. Well, we already know what pi is, but what we want to do is we want to have pi on this side, everything else on that side. So what do we have to do? Well, there's a couple things we could do. So let's rewrite our equation first. Well, we could first get rid of this 4/3. So if we do that, we can multiply by the reciprocal 3/4. So that gives us 3v over 4 equals pi r cubed. Okay. Now, because I kind of have fractions on this side and no fractions here, it's probably best the next thing we need to do is multiply by the reciprocal. So I want pi, so I have to get rid of that r cubed. So let's multiply by the reciprocal 1 over r cubed. So I'll multiply by 1 over r cubed. Now those cancel and I just have pi on this side. So I have pi equals what? Well, I have 3v times 1, which is 3v, and r cubed times 4, so that's going to be a 4r cubed. And so this then has solved my equation for pi. All right, so what about the next one? Well, we've got t equals big D minus little d divided by L, and we want to solve for big D. So what we have to do is first is get rid of that L because that's not going to help us at all there. So if we have t equals d minus d over L, if we multiply by L on both sides, that gets rid of it, and then we have something we can just add little d to both sides and we'll be pretty much done. So it looks like now we have LT equals d minus little d. Now I need to solve for big D, so let's add little d to both sides. And so big D equals LT plus little d. And now I have solved my formula here for the capital D. Now I've got the 2m plus p equals 4m plus 9, and I want to solve for m. All right. Well, let's start just from this equation here. Let's subtract 9 and subtract 9. Let's also subtract 2m. And so now those cancel, and on this side we have p minus 9 equals 4m minus 2 is 2m. So we're almost there. Now we divide by 2, and so I get m equals p minus 9 over 2. Okay. Now you could have done it in multiple steps, maybe first subtracted the 2m and then the next step subtracted the 9. Or, if you're comfortable doing 2 steps at a time like I just did here, that's fine as well. What about this one? Now we want to solve for t. So there's t only right here. So I need to get rid of that bw. So let's add bw. So when we do that, we get AT equals S plus BW. Now I need to solve this for T, so I need to divide by A. And so that gives me T equals S plus BW all over A. Okay. So again, these aren't hard things to do is just literally solving for one of the variables, no matter which one they gave us. We could have solved for W here. We could have solved for B or A or S. We've already got solved for S. We don't have to do that one. But we could solve any of the variables. So that's kind of a nice thing, is to be able to rearrange an equation and have it solve for the variable that you need to have it solve for. All right, what about this one? Well, this one looks like it's going to be a little more complex. So we want V2. So we want this piece here by itself. Well, that means we have to get rid of that G first, so then we can start doing other stuff. So let's say we have P equals V1 times V2 minus V1 all over G. So if we multiply by G, that's going to cancel it there. And if we multiply by G there, we get the following. Now, to get to the V2, we have to get rid of this multiplication, so we have to divide by V1. So now we have GP over V1 rather, equals, now we have V2 minus V1. Now we want V2, so all we have to do is add V1 to both sides. And so now what we have is, if we take the V2 to the left, V2 equals, now we have GP over V1 plus V1. Okay. Now they never said we had to get common denominators and add everything together like that. So I think this would be fine. If we had to get a common denominator, well, that's going to be the V1. So we're going to multiply by V1 over V1. And then that would be GP plus V1 squared all over V1. So that would be what it would be if we had to actually get a common denominator, but I don't think we have to. And so, this then would be probably as far as we need to go on this one, although this one technically is correct as well. All right, let's pause there and we'll come back for more.